Alright, here we go. Lesson 1.6, linear scale factors and area. So investing the relationship between linear scale factor and area scale factor. So linear, you got to think in a line. Area, you're talking surface area. So complete the following table to investigate the relationship between linear scale factor and area scale factor. The first one has been done. So let's take a look at that. So you can, in your notes, you can even draw a little sketch on the side for your own information. But here we go. We got the first one is a 3 by 5 rectangle. So if you picture this rectangle, 3 by 5. So that's the original dimensions. The original area, if we multiply 3 by 5, we get 15 centimeters squared. So the scale is 2 to 1. That's what we're going to apply to it. It has a linear scale factor of 2. So each of these dimensions need to be multiplied by 2. So 3 times 2 is 6. 5 times 2 is 10. So the new dimensions of a rectangle, 6 by 10. And the new area will be 60 centimeters squared. So now we're going to look at a thing called area scale factor. So our linear scale factor was 2. So let's take a look at the new area. So the new area is 60, and the old area was 15. New area is 60, old area is 15. So if we divide that, 60 divided by 15, we actually get an area scale factor of 4. So when we increase the dimensions by 2, the area actually increased by a factor of 4. So keep that in mind as we do the next one here. So the next one, the original dimensions are 9 by 6. So again, you can draw yourself a little sketch, 9 by 6. So the original area, 9 multiplied by 6, will give us 54 centimeters squared. And then we're going to apply the scale factor of 1/3. Okay, so scale factor 1/3. So each of these things gets divided by 3. So 9 divided by 3 will be 3. And 6 divided by 3 is 2. So the new dimensions are 3 by 2. So the new area is going to be 6 centimeters. So we take the new area, 6, we divide it by the old area, 54, and we get a an area scale factor of 1/9 when we reduce it. So the linear scale factor was 1/3, but the area scale factor is 1/9. So let's keep investigating this. So 4 by 8, the original area is going to be 32 centimeters squared. We're applying a 3 over 2 linear scale factor. So if you divide 3 by 2, you get 1.5. So if we multiply each of the original dimensions by 1.5, we'll get new dimensions of 6 by 12. If we multiply 6 by 12, we get 72 centimeters squared. So let's take the new area, 72, divide it by the original area, 32, and we'll get an area scale factor of 2.25. So again, the original linear scale factor was 3 over 2, and the area scale factor is 2.25. So that means the area is 2.25 times bigger than it was before. So here we go, last one, 3 by 6, the original area is going to be 36 centimeters. We're applying a linear scale factor of 2/3. So if you divide 2 by 3, you get 0.66666, repeating. If you multiply 3 by 0.6, you'll get 2, and if you multiply 12 by that, you should get 8. Oops. So the new area is 16. So let's again investigate our new area divided by original area. So 16 divided by 36, and we actually get 0.44 repeating. So why is the area scale factor different than the linear scale factor? Well, it all comes down to that each dimension, this dimension and this dimension, are both being multiplied by a scale factor, so they're both getting bigger. So if this is getting multiplied by a scale factor of 2, like in the first example, and this dimension is also getting multiplied in this dimension by 2, well, the whole thing gets multiplied by a factor 4. 2 times 2 is 4. Same thing goes with the other scale factors that we talked about here. Again, if the scale factor was increasing this way by a factor 3 over 2 and increasing this way by a factor 3 over 2. Well, it's going to be 3 over 2 times 3 over 2 will be your area scale factor. So the area scale factor is the linear scale factor squared, okay? Or linear scale factor is going to be the square root of the area scale factor. So Maggie has scanned an 8 by 10 photograph to her computer. Maggie would like to increase the size area by 44%. 44%. So we need to determine the area scale factor and the linear scale factor. Well, let's just draw a little sketch here. So there's our photograph, 8 by 10 centimeters. Now each one of these dimensions is going to get multiplied by a scale factor of increasing by 44%. So it's going to get multiplied by 1.44. So that's 100% the original plus 44%. And this will also get multiplied by 1.44. So 10 times 1.44 is going to give us 14.4. 14.4 by 8 times 1.44 is 11.52. So that's the new dimensions. So the linear scale factor is going to be by 1.44. Now if we go back to the area scale factor is the linear scale factor squared. If we square 1.44, that equals 2.0736. So that's what you're going to multiply the area by. Explain why these scale factors are different. This is because each dimension, each linear dimension, increases. Determine the dimensions of the enlarged photograph. So we did that here. The enlarged photograph will be printed at a digital print shop on a color printer. Assuming the white areas of the photograph will also use ink, calculate the area the printer must cover by the following two methods, using the dimensions of the enlargement or using the original area and area scale factor. So, using the dimensions of the enlargement, if we go 14.4 times 11.52 centimeters, that will give us a new area of 165.88 repeating. If we use the original area of 80 and we multiply that by our new area scale factor of 2.0736, we will also get 165.8 repeating. Okay, a couple quick hitters here on page number 2. Marco, owner of Mapit, produced a map of Canada with his employees. The area of the province of Alberta is approximately that big. On Marco's map, the area of Alberta is represented by a much smaller area, 264.74 centimeters squared. The scale of the map, linear scale factor, can be written in the form 1 to x. Calculate the value of x to the nearest whole number. So we need the linear scale factor. Well, we can figure out the area scale by taking the original 661,850 and dividing it by 264.74. And if we do this, you actually get a scale factor of 2500. That's the area scale factor. Now we need to take the square root of this to figure out the linear scale factor, and it will be 50. So the linear scale factor is 1 to 50. So for every 1 centimeter on the map, it actually equals 50 kilometers. Okay. On the same map, the province of British Columbia is represented as that. So determine the actual area of BC to the nearest square kilometer. So if we take 376.839 centimeters squared, and we multiply that by our factor of 50, we'll get an actual area of 942,098 kilometers squared.